Okay, continuing our review, these problems are from sections 4.1 and 4.2. So use synthetic division to determine if x plus 3 is a factor of the polynomial you see here. So if I'm trying to find if x plus 3 is a factor, that means I'm looking to see if x equal negative 3 is a solution. So to set up this synthetic division, I write minus 3. And then I'm going to have all the coefficients of the polynomial. So it looks like I'm going to have something for x to the 5th, x to the 4th, x cubed, x squared, x, and a constant. So my x to the 5th term is 2, 6x to the 4th, minus 9x cubed, minus 27x squared, 4x, and a constant of 12. So bring down this 2, multiply and get negative 6, and sorry about that, then I get a 0. Multiply here and I get a 0, I get a negative 9. Multiply and get 27, add to get 0. Negative 3 times 0, add that to get 4. Negative 3 times 4, negative 12, add that to get 0. So if I look at this bottom row, this corresponds to my x to the 4th. That's my x cubed, x squared, x, and constant. Okay. Because I have a 0 remainder, that means that x plus 3 is a factor, okay? Because of having the 0 remainder, okay? Let's do another one of these. Determine if x minus 1 is a factor of this polynomial. So x minus 1, if that is a factor, I'm testing to see if x equal 1 is a solution or root, okay? So to set up the synthetic division, I put a 1 out here, and then the coefficients of everything that I have. So it looks like I'm going to need, since this is x to the 4th, I'm going to need an x to the 4th, an x cubed, an x squared, an x, and a constant. So if I write down those coefficients, I've got 1x to the 4th, 0x cubed, minus 13x squared, 0x, and a 36. Okay, there are a couple of 0 placeholders that had to be put into this problem. So if I bring down this first number, 1 times 1 is 1, add to get 1, 1 times 1 is 1, add to get negative 12, 1 times negative 12 is negative 12, and then 1 times negative 12, add that to get 24. So I have a non-zero remainder. That means that x minus 1 is not a factor. Let's look at problem number 7. What is the degree of this polynomial? Okay, so it looks like I'm going to get an x squared term out of that one, an x, and an x cubed. So it looks like 3, 4, 5, 6, 7. This is a 7th degree polynomial. Okay, what is the leading coefficient? So it looks like with the leading coefficient, I'll get a negative 2 from that term. And then I'll get a 1 from the next x, a 1, 1, and a 1. So negative 2 is the leading coefficient. What are the roots, okay, or the solutions or the zeros? So it looks like the roots of this are going to be at x equal negative 3, 2, negative 2, and 1, okay? And list all roots with multiplicity. So there are 2 of those. Looks like there's a multiplicity of 2 there and a multiplicity of 3 there. So the way that we write this, there is a multiplicity of 2 at x equal negative 3 and there's a multiplicity of 3 at x equal 1. Okay. Problem 8, if we continue with this, I'm given that x minus 2 is a factor, and I'm asked to factor this polynomial completely. So if x minus 2 is a factor, so x minus 2 is a factor, that means that x equal 2 is a solution. So when I do synthetic division with a 2, I'm expecting to get a 0 remainder. So I'm going to have x cubed 6x squared minus x minus 30. So if I bring that 1 down, 1 times 2 is 2, I get an 8. 2 times 8 is 16, add that to get 15. 2 times 15 is 30, so I have a 0 remainder, okay? So that means that f of x is equal to, having this 0 remainder means that x minus 2 is a factor. So I can write this as x minus 2 times, I look at this bottom line, that means this is my, if that's my x cubed term, this has to be my x squared term. So that is x squared plus 8x plus 15. Okay. Now I'm asked to factor this completely, so it boils down to, can I factor this? So x squared plus 8x plus 15, that will factor if we can find two numbers that multiply to 15 and add to give me an 8. Those numbers are 5 and 3. So this is x plus 5 times x plus 3. So that means the final factorization is x minus 2, x plus 5, x plus 3. Okay. So I started out with one synthetic division to get the cubic down to a quadratic, and then we know how to factor quadratics. Okay. Number 9, what is the degree? Okay, to find the degree, I'm going to get an x to the 4th out of that term, an x, and an x squared, so 4, 5, 6, 7, 8. This is an 8th degree polynomial. Its leading coefficient, the first term will give me a 1, second term will give me a 3, a 1, and a 1, so the leading coefficient is 3. 8th degree polynomial, leading coefficient of 3. What are the roots, the zeros, the solutions? That is going to be x equal negative 1, and then 2/3, negative 7, and 3. You get that by setting each factor equal to 0. And multiplicity. So there's a multiplicity of 4 at x equal negative 1. There's a multiplicity of 2 at x equal 3. Okay. And the last one here. So given a 3rd degree polynomial and one of its factors, list all of the factors and list all of the roots or solutions. So I know that x equal negative 4 is a solution. That means that x plus 4 is a factor. Okay. So if I do the synthetic division, I'm going to start with a negative 4. And then I'm going to have my x cubed term, my x squared, my x, and my constant. So the coefficient of the x cubed is 6. The coefficient of x squared is 25. And then 3 and minus 4. So if I bring down the 6, I get negative 24. Add that to get 1. Multiply to get negative 4. Add to get negative 1. Multiply this to get 4 and a 0. Okay, so that means that this is a factor. So f of x equals, here's my factor, x plus 4, and then I just need to read the solution that I found. That's my x squared term, my x, and my constant. So this is 6x squared plus x minus 1. Now, I need to be able to factor this. So let's come off to the side. 6x squared plus x minus 1. That will factor if I can find two numbers that multiply to give me a -6 and add to give me a 1. Okay? So the numbers that multiply to give you -6 and add to give you a 1, that will be a 3 and a -2. Okay? So I'm going to rewrite this problem as 6x squared plus 3x minus 2x minus 1 using these two numbers. And then if I factor out a 3x from the first two terms, I get 2x plus 1 minus 2x plus 1. So this is 3x minus 1, 2x plus 1. That's the factorization. So that tells me if I come back over to my problem over here, f of x is equal to x plus 4, and then 3x minus 1, 2x plus 1. So that answers the part about factoring completely. Now to list all of its roots. If x plus 4 equals 0, then x equals -4. If 3x minus 1 equals 0, then x equals 1/3. If 2x plus 1 equals 0, then x equals -1/2. Okay? Those are the three roots or solutions to the polynomial. So that is it for the review. We did not review all of Unit 3, just the even-odd algebraic, but it does show you all the different topics we covered in 4.1 and 4.2.